So to continue on with our chemical reactions story, some of the chemical reactions I mentioned in the previous video, combination, decomposition, single replacement, and combustion, but not double replacement, can also be considered redox reactions or oxidation reduction. Okay, oxidation reduction. You've heard of the term oxidized, or when you have a really old car and it starts to rust and you say the iron got oxidized. Oxidized, just a more technical term for rust. So what is oxidation? What is reduction? How is it that we can identify that some reactions are redox reactions and some reactions are not redox reactions or non-redox? Let's first define the terms. Oxidation is basically a loss of electrons. So if something loses electrons, we say it got oxidized. And reduction is a gain of electrons. Now, how are we supposed to track those electrons? How are we supposed to know if an element lost electrons or gained electrons? The way we do that is we assign oxidation numbers. So we're going to learn how to assign oxidation numbers. And what you're going to see is that in oxidation, the oxidation number goes up. So if an element got oxidized, you're going to notice that its oxidation number went up. So maybe it was at a 0 and now became a 2. Or maybe it was at a -1 and now became a 0. So if the oxidation number goes up of an element, that element got oxidized. And it's the same thing as saying it lost electrons, oxidation number went up, that element got oxidized. If an oxidation number goes down, if the oxidation number goes down, so let's say an oxidation number was 0 and now it went down to -2. So that element gained electrons, it caused its oxidation number to go down, that element got reduced. Okay, so that's an overview. Now let's learn how to actually assign oxidation numbers so that we can begin to look at reactions and decide which element got oxidized, which element got reduced, and get into that terminology. But first, let's talk about the rules for assigning oxidation numbers. Okay, rule number 1. Your book has all of this stuff, but rule number 1 is that anytime you see an element alone, its oxidation number is equal to 0. So for example, if you see iron alone, not in ionic form, just iron, oxidation number 0. You see hydrogen element alone, oxidation number 0. You see, let's say sulfur oxide by itself, or S8, let's say. Sometimes sulfur exists as this polyatomic molecule, oxidation number 0. You see chlorine, again, one of those diatomic molecules, 0. You see zinc, all by itself, 0. So anytime an element is by itself, oxidation number is automatically 0. So that's rule number 1. The oxidation number of ions, of monoatomic ions, is the charge of the ion. So that would be rule number 2. So for example, if you have a sodium ion sitting around by itself, but you can see that it's an ion, not just an atom, an ion, so its oxidation number is +1. If you see it as part of a compound, and you know that that compound is an ionic compound, then you say, okay, what is the oxidation number of the sodium? It's +1. Oxidation number of the chloride, -1, because that's what their charges are. And you already know the charges of the metals. The ones that are, you remember from the previous chapters, group 1A is always +1, group 2A is always +2, aluminum, gallium +3, these are the fixed charge ones, zinc, cadmium +2, and silver +1, and everything else is variable. You remember all of that. All right, rule number 3. If you have a compound, then the sum of the oxidation numbers is equal to 0, which we just saw with sodium chloride. Sodium's +1, chloride's -1. You add them together, you have an oxidation number of 0. And the sum is 0. Now, if you're dealing with covalent compounds, it gets a little tricky. These are ionic, really easy. Let's say you have a covalent compound. These are some rules that will help you out. Hydrogen is usually +1. Oxygen is usually -2. And fluorine is always -1. So if you're seeing these in covalent compounds, this rule is going to apply. All right, so let's see what I'm talking about. You know that the sum has to equal 0 and that this thing is important too. So let's say I have something like this, carbon dioxide. What would the oxidation number of the carbon be? Well, according to this rule, oxygen is usually -2. So I have 2 of them. -2 times 2 is -4. The carbon, I don't know what it is. It's an X. Remember the rule that said the sum of the oxidation numbers in a compound has to equal 0? So we go X plus -4 is equal to 0. So you manipulate the equation. What is X? X is equal to +4. Okay, remember your basic algebra here. So the oxidation number of this carbon is +4. Well, what if I had carbon monoxide, not carbon dioxide? Well, this oxygen is -2, according to this rule here. So this carbon must be +2. How did I know it was +2? Because the sum of the oxidation numbers has to equal 0. All right. Another rule. The sum of the oxidation numbers of the elements in a polyatomic ion, equals the charge of the ion. Okay, what do I mean by that? Let's take a look. Let's say I've got this. Recognize this as the nitrate polyatomic ion. All right, so I know from the previous rule that oxygen is -2. So if oxygen is -2 and I have 3 of them, -2 times 3 is -6. Now I don't know what the nitrogen is. So I'm going to say X plus -6 equals. In this case, it's not a neutral compound, so it's not going to be equal to 0. This rule says that the sum of the oxidation numbers of a polyatomic ion has to equal the charge of the ion. So this is going to have to equal -1. All right, so you manipulate the equation, you solve for X. What would X be? +5. So the oxidation number of the nitrogen is +5. Again, remember your algebra rules. All right, let's practice a few of them. Let's see what you guys can do. Let's say I have this thing. Let's say I have this. And let's say I have this. And let's say I have, all right, so I have 3 things over here. I have sulfur trioxide, I have the sulfite polyatomic ion, and I have potassium chlorate. All right, so I want to know the oxidation number of this sulfur, and this chlorine. The others I should know already. How come? Because the rule said the oxygen is usually -2. So this is -2. I have -2 times 3 of them. I have 3 of them. That's -6. So this is -6. This is my unknown, x. X plus -6 has to equal 0. How did I get the -6? Remember the rule that says oxygen is -2? So -2 times 3 is -6. This is x plus -6 equals 0. So therefore, this sulfur must be +6. Good. Let's try this one. I know that oxygen is -2, and I have 3 of them. That's -6. This sulfur is my unknown. But see how this is a polyatomic ion? So the sum has to equal the charge of the polyatomic ion according to that rule I just gave you. So what would the sulfur be here? Notice here it was +6, but here, in order for this plus -6 to equal -2, this becomes +4. Again, manipulate the equation. Some of you can do this in your head. Some of you will just set up an algebraic expression and solve for x. Okay? And then finally, potassium chlorate. Now, potassium is a group 1A metal. It's never going to change. It's always +1. So I already know that this is +1. Oxygen, the rule says it's -2 times 3, -6. Okay, so this is my one unknown now. So +1 plus x plus -6 has to equal 0. Why 0? Because it's a neutral compound. The sum of the oxidation numbers is going to equal 0. The only time the sum of the oxidation numbers is not equal to 0 is if you have a polyatomic ion. All right, so what would x be? X, and again, manipulate the equation. X would be equal to +5. Okay, and that's how you figure out oxidation numbers. Your book has lots of practice, so does your homework, so you should be all set. Next video, we will talk about using these oxidation numbers to figure out which element got oxidized and which element got reduced in an equation or in a chemical reaction. Okay.